So looking at 7.2b, it's pretty much the same as 7.2a. 7.2a was solving exponential equations. Now we're just going to solve an exponential inequality. Okay, so that's where you have that greater than or less than sign. So, right now. So solving exponential inequalities, an exponential inequality is an inequality involving exponential functions. So our property here, you have b greater than 1, then b to the x power is greater than b to the y power if and only if x is greater than y. So again, we're looking at these exponents, okay, and they need to have a common base here. So your base needs to be the same in order for you to say x is greater than y. Okay, same thing if it was less than, okay, your bases have to be the same, then I can say x is less than y. Okay, so an example of this, if I have 2 to the x power is greater than 2 to the 6th power, then I can say x is greater than 6. Okay, since my bases are the same. So looking at an example, okay, we want to solve 16 raised to the 2x minus 3 power less than 8. Okay, so I want to change both of these numbers to have a common base. Okay, what kind of common base do you think I'll have for these two? What? 2. Okay, so I can change this 16 to a base of 2. What do I have to raise 2 to the power of to get 16? 4. Okay, so I have 2 to the power 4, and that's still raised to the 2x minus 3 power. Okay, and then what do I have to change this 8 to? I need a common base, so my base is still going to be 2. 8 is 2 to the power of what? 3. Okay, so now that I have this common base of 2, what I can do with this power here, again, you have to distribute that 4 to both terms. Okay, so I would have 2 to the power of 8x minus 12 is less than 2 to the power of 3. Okay, so I have my common bases. That means I can take my exponents and my less than sign here and write 8x minus 12 is less than 3. So again, first step is to get that common base, and then you can take your exponents. So from here, I just need to solve for x. So I'll add 12 to both sides of my inequality. So I have 8x is less than 15. Tyson. Okay, then divide both sides by 8. So x will be less than 15/8, or if you put it into your calculator, get a fraction, you could also say x is less than 1.875. Okay, either way. So keep it as a fraction if you want, or you can write it as a decimal. Okay, questions on that first example?
So we can just write the 15 over 8, right?
Yes, you can write the 15 over 8. Okay, example 2, same thing. We want to first get a common base number. You taking it now? Okay, so common base number. This one, I have 2 to the x plus 2 power, and I have 1 over 32. Now, if I have 1 over a number, I have this fraction, right? Do you remember how to switch that into an exponent? What would I do? What would be different about my exponent to get a common base here? So it'll be, you'll have a negative exponent getting that common base. So here, I'm going to keep a common base of 2 since I can't change 2 to any type of power. I can't reduce it. So I'm going to keep this as 2 to the x plus 2 power. But I'm going to change this 1 over 32, to a base of 2. Now 2 to what power is 32? 5, right? So it'd be 2 to the negative 5th power then. Okay, so it'll be to this negative 5th power. That way it makes that fraction. Do you understand how I did that? No? So if I were to change this, right, 2 to the 5th is 32. I'm adding in a negative because that negative flips it to the denominator. Okay, because I want this common base of 2. Since this base was already 2, this base has to be 2. Okay, so I need to manipulate this 1 over 32 to make it a base of 2. And 2 to the 5th is 32, but I'm going to add in this negative so it flips it to the denominator. So now that I have my common base, I can take those exponents. So I have x plus 2 is greater than negative 5. Subtract 2. So x is going to be greater than negative 7. Okay, questions? It's really similar to what we did last week with our expressions, just now it's an inequality instead. All right, then if we go to the back, I'm going to go over compound interest. So exponential functions are used in situations involving compound interest. Compound interest is interest paid on the principal of an investment and any previously earned interest. So I do give you the formula here. Okay, so we calculate compound interest using this formula. Okay. Now it tells you what each of these variables is. So this capital A right here, that is the amount in the account after T years. Okay, so A is the amount in the account after T years. Okay, and T then, in our formula here, is your time in years. Okay, so T is your time in years. Okay, then we also have P. Okay, P is the principal amount invested. So what you invested that first time. So I put in $1,000. That would be your principal amount. Okay, and then R is the annual interest rate. So it's the rate of interest that you would accumulate. So R is rate. And then lastly, N is the number of compounding period years. Okay, so how many times it is compounded per year. So it could be on a weekly basis, it could be on a monthly basis, it could say biannually, okay, stuff like that. So, looking at our example, I did highlight this different colors so I could highlight it in our example here. So an investment account pays 4.2% annual interest compounded monthly. Okay, so that 4.2% is your interest rate. Okay, so that's what I highlighted here as orange. Okay, so that 4.2% is your rate. Okay, now that is compounded monthly. Okay, so compounded monthly means you're doing it every month within that year. Okay, so that is your number of compounding periods in a year. It's monthly. Okay, so if I have, or if $2,500 is invested in this account, what will be the balance after 15 years? Okay, so originally we invested $2,500, so that is your principal amount invested. Okay, that's how much is in your account. Okay, and it asks what will be the balance after 15 years. Okay, so that's your time, how many years you're doing this over. Okay, so that's T. All right, so I'll write this out then as each variable. So we have R. R is your rate, or how much percentage you get compounded, or how much interest. So that is 4.2%. Now, in order to put this into our formula, we have to write that as a decimal. Okay, so change your percent into a decimal. That'd be 0.042. Okay, so you just divide it by 100. Okay, so that was our rate. Next is how many compounding periods we have in a year. That's your N. Okay, since it is monthly, how many months are in a year? 12 months. Okay, so our N value is going to be 12. If it was daily, you'd say 365. Okay, next we have P. So that's our principal amount invested. So that is $2,500. And then T is the time or how many years we're going to do it for. Okay, and that is 15. Okay, so we want to see how much money is in this account. That's your A value, the amount in the account. So we're just going to plug in our numbers. So we have A is equal to, our P value is 2,500 times 1 plus R. Okay, R is 0.042 over N is 12. Okay, that's raised to the N 12 times T 15 power. Now I would be careful entering this into your calculator all at once. What I suggest you do is enter what's in your parentheses here first. So 1 plus 0.042 divided by 12. Okay, so that's what I did. So I have 2,500 times 1.0035. Okay, and I just rounded, I believe. And then I multiplied 12 times 15 to get that bigger power there. And 12 times 15 is 180. Okay, and that'll make it a little bit easier then to enter it into your calculator. So you should get about $4,688.87 in your account after 15 years. So initially we put in 2,500. After 15 years we'll have 4,688. Yeah. So again, when you're doing these compound interest problems, you do have to be careful with your N values. So this one was compounded monthly, right? So there's 12 months in a year. Sometimes you'll get compounded weekly. Okay, so if it says compounded weekly, do you know how many weeks are in a year?
52.
There are 52 weeks. So 1 year is 52 weeks. Okay, so if it says compounded weekly, you write N is 52. If it says it's compounded biannually or semi-annually, that would be twice in 1 year. So N would be 2. Okay. Is there 2 N's in that? Yeah. Okay, and if it was compounded daily, you'd say 365 for N. Okay, so that's how you kind of have to look at it. So how many times is it compounded within that year to find N? And usually that percentage that it gives you in your problem is your rate. Okay, you just have to change it to a decimal.